Assalamu alaikum students. Our lesson 2 of this week is about factorization. By the end of the lesson, you will be able to factorize algebraic expressions of type a square plus or minus 2ab plus b square minus c square with the help of the algebraic identities. In these expressions, there will be four terms given, and we will be dividing these four terms into two parts. And in the first part we will take the first three terms, and in the second part we will take the last term only, and the sign between both the parts will be minus sign always. And here with 2ab sign will be either plus or minus. So it means in the first part we can apply first identity or second identity, and when we combine this part, the first part with the second part, we will apply third identity. So in this exercise we will use all of the three identities. With the help of these three identities, we will be able to factorize these type of expression. Here we have an example. We have a square plus 6ab plus 9b square minus 16c square. First of all, we have to break this expression into two parts. In the first part, we will take first three terms, a square plus 6ab plus 9b square, and in the second part we will take the last term only, 16c square, and this must be a perfect square always, and this sign between both the parts must be minus sign. So now if you observe the first part, you can see we can apply first identity. To apply the first identity, we should have two perfect squares. So we have two perfect square. A square is perfect square of a, and 9b square is perfect square of 3b. In case if we have minus sign here instead of plus, so we will apply second identity, but we have all plus sign in the first part, so we will apply first identity in on first part. So a square is square of a, and 9b square is square of 3b. Now we will break our middle term in the format of 2ab. So 2, and in the first bracket we have to write the first perfect square a, in the second bracket we have to write the second perfect square 3b. Now we will match the terms. Square of a is a square, 2 into a into 3b is 6ab, and square of 3b is 9b square. Then we have minus sign, we'll write minus sign, and 16c square is perfect square of 4c. So using the first identity, a square plus 2ab plus b square is equals to a plus b whole square, we have discussed this, that this format a square plus 2ab plus b square is the expanded format. From that we will write the short format, or factorized format, which is a plus b whole square. So on the first part, if we apply first identity, we get a plus 3b whole square, minus 4c square will remain same. Now you can see we have two perfect squares and minus sign in center. Now we will apply third identity, which is a square minus b square is equals to a minus b, a plus b. So here your a, which is your first term, is a plus 3b, and your b is 4c. So we get a plus 3b plus 4c, a plus 3b minus 4c. So after factorization, we get two factors, a plus 3b plus 4c and a plus 3b minus 4c. So it means on the first part, which has three terms, we will apply first or second identity, and we will come after applying the identity, we will combine that with the last term and apply third identity. Now students, we will review all types of the expressions and their factorization. We have learned five types of factorization. In the first type of factorization, when an expression will be given, there will be two or more than two terms given. I have taken three terms in the example. Now in this type of expression, there will be a common factor from all the terms. We can take common from all the terms. So you can see 77, 33, and 55 are divisible by 11. So 11 is one of the common factor, and x square y, x y square, x square y square, in the variable xy is common. So in this type of the expression, all of the terms have one common factor. So 11xy is common. So if we take 11xy common from the first term, 11 times 7 is 77, so we get 7. We have taken y common, and from x square we have taken x common, so x is remainder. Then we have minus sign. 11 3 is a 33, we have taken x common, and from y square we have taken only y common, so we get 3y. Similarly, if we take 11xy common, so from 55 x square y square we get 5xy. Now in the second type of expression, you can see that we cannot take common from all the terms. Like if we break this expression into two parts, like in this example we have y square minus 9y plus 3y minus 27. We have common from the first part and we have common from the second part. We have common y from y square minus 9y, and we have 3 common from 3y minus 27. So the difference between both of the types is, in the first type we have common factor from all of the given terms, and in the second type we have common in the first two terms and we have common in the second two terms. We don't have a same common factor from all the terms. So let's start this example. From the first part, the common factor is y. If we take y common, we get y minus 9, and from the second part we have 3 common, so we get y minus 9. These two brackets will be same always, so y minus 9 is common. We will take it as a common factor, and the remainder will be y plus 3. So after factorization we get y minus 9 into y plus 3. Now we have third type of expressions in which we will be applying first or second identity. We can have a square plus or minus 2ab plus b square. There will be two perfect square, and the central term will be in the format of 2ab. Let's learn this with the help of an example. We have x square minus 8xy plus 16y square. We have discussed that we have to see two perfect squares first of all, and here the two perfect squares are x square and 16y square. X square is square of x and 16y square is square of 4y, and we will rewrite the middle term in the format of 2ab. So 2 in the first bracket, write the first perfect square x, and in the second bracket write the second one, which is 4y. Now you can match the term. Square of x is x square, 2 into x into 4y is 8xy, square of 4y is 16y square. So from this format we will the expanded format, we will write the factorized format x minus 4y whole square. This sign minus sign depends upon the sign with 2ab. In case if we have plus sign here, we will write plus sign here. Now the fourth type of expression is a square minus b square. There will be two perfect squares and minus sign in center, and we will apply third identity. So here we have an example, y square minus 9. So y square is perfect square of y and 9 is perfect square of 3, and we should have minus sign in center. So after applying the third identity, we get y plus 3 into y minus 3. Now the last type is a square plus or minus 2ab plus b square minus c square. We will have four terms, and we will break the terms into two parts. We will take the first three terms in the first part and only the last term in the second part, and on the first part we will apply first or second identity, and we will combine it with the last part, second part, and apply third identity. So you can see on the first part we have two perfect square, x square and 4y square. 4y square is perfect square of 2y, and we will break the middle term in the format of 2ab. And after applying the second identity from the first part, we get x minus 2y whole square, and z square is perfect square of z. So now we will apply third identity. We have two perfect squares and minus sign in center, so we will apply third identity to get a plus b, a minus b. Here your a is x minus 2y and b is z, so we get x minus 2y plus z, x minus 2y minus z. So I hope after reviewing all types of the expression and how to do their factorization, you can easily do exercise 6.2 and 6.5, and you can easily differentiate all the expressions, and you can easily see how to factorize them.